Hi everyone, we're going to get started on section 9.4, and this is where we're going to be doing a process called completing the square. It's a pretty long and involved process, so make sure you have a little bit of time before you get started here. Okay, so here we go with completing the square. So section 9.4, completing the square, and this is going to be the reason why we call this process completing the square. As you can see, we've got an algebra tile set here equal to -2. And the idea is what do I need to add to this section right here in order to make this area a square? Well, it looks like I have to add 1, 2, 3, 4 tiles to do that. So as you can see in letter B, if I add 4 tiles here, I've got to add 4 tiles here on the right side too. And we have some 0 pairs. This cancels out here, this cancels here. So this is equal to 2. And of course, when you factor on the left side, you've got x plus 2 and x plus 2. So the equation that we have here is x plus 2 times x plus 2 equals 2, which is another way of saying x plus 2 squared equals 2. So that's the process of actually completing the square. It's adding a bit to both sides of the equal sign so that on the quadratic side you create a perfect square. And by perfect square, I mean this right here. You've got that thing squared, something squared. Here's exploration 2. We're going to do something similar with this. So the first thing is, if I want to complete the square, what do I need to add? I need to add 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles in order to complete the square. So I have to add 1, 2, 3, 4, 5, 6, 7, 8, 9. So write the equation in terms of algebra tiles. Well, as it stands, you've got an x squared plus 1, 2, 3, 4, 5, 6 plus 6x is equal to -1, -2, -3, -4, -5. So we've gone ahead and we've completed the square, and then we're going to write out the solutions of the equation. Well, let's see. If I complete the square, I will get, how much is this? X plus 3, and then x plus 3. So this is x plus 3 squared equal to, and then let's cancel out the 0 pairs. I'll cancel them out in red. Cancel with that, this one with this one, cancel out that with that, this with this one and this one. And so I've got 1, 2, 3, 4 leftover tiles. Okay. And now we're going to go ahead and solve that, okay? So if I square root both sides, I can get that x plus, well, no, let's do this. Let's actually square both sides, square root both sides, square root of 4. And that tells me that x plus 3 is equal to positive or negative square root 4. Well, what is the square root of 4? That's just 2. X plus 3 is equal to positive and -2. Now you'll notice that there are 2 solutions here. So let's go to the 2 solutions. The first one is x plus 3 equals -2. And if I solve that, I get x plus 3 minus 3 equals -3 minus 2, or x equals -5. The other solution, x plus 3 equals positive 2. And then if I add a -3 to both sides, x equals -1. So my 2 solutions are x equals -5 or x equals -1. Moving on, here we go with communicate your answers. So how can you use completing a square to solve an equation? Well, the idea here is to write the equation in a specific form, which would be x squared plus bx equals d. And then to complete the square, I don't know if you've noticed, but you're going to have to take the b, divide it in 2 first, and then square as a result. So you're adding b over 2 squared to both sides. Let's see this in action. We're going to take a look at letter A. Let's zoom in a little bit at A. And let's get started. So the first thing to do is notice that we are in that same form. That form is x squared plus bx equals d. So just equating the parts here, I can see that b is -2 and d is 1. Now the d doesn't really matter as much as but b is. The value of b is -2. And I'm getting tired of it doing that, but you're going to take b and divide it by 2 and then square it. So how much is b? It's -2. -2 divided by 2 is -1. And then -1 squared is 1. So I'm going to be adding 1 to both sides of the equal sign. Also important, which I don't think the book talks about, is that quantity of b over 2. b over 2 is -2 divided by 2, which is -1. And we'll see why that's important in a second. Here's what we're going to do. We're going to add +1 to both sides. And that +1 is that b over 2 squared. If you add +1 to both sides, you'll notice that on the left side, you've created a perfect square polynomial. And the right side is just 1 plus 1, which is just 2. So you have x minus 1 squared, which is the factored form of the polynomial on the left, is equal to 2. Next, you're going to take a square root of both sides, which gets you that x minus 1 equals the positive and negative square root of 2. Finally, you're going to add 1 to both sides because I don't want to solve for x minus 1. I want to solve for x. So if I add 1 to both sides, I get x equals 1 plus or minus square root of 2. And that's our answer. You can use your calculator to turn that into a decimal form if you need to. A good number to memorize, especially if you're going into higher math, is that the square root of 2 is about equal to 1.414. So that's letter A. The answer is, I think, -0.414 and then 2.414, somewhere around there. Let's look at B. I think it'll be a little more illustrative than letter A was because there were too many of the same numbers floating around. So let's take a look at B and try to figure out, well, what is my value of B? And looking at that, it looks like B is -4, and that D is -1, which of course is not as important as -4. So we're going to take B and divide by 2, and you're going to get -2. That -2 will be an important number. And then you're going to take that -2 and you're going to square it, and you're going to get +4. And that +4 is also going to be an important number. We're going to use both -2 and +4. So the first thing you're going to do is add 4 to both sides. On the left side, you will notice that you get a perfect square. And on the right side, you just get -1 plus 4, which is 3. So when you factor the left side, you get x minus 2 squared equals 3. And take a look at what we have squared, x minus 2. Isn't that minus 2 the same thing as b over 2? And it is. So you don't even really need to factor here. It's just x plus b over 2 squared. Okay? That's always going to be over 2, a b over 2, and we're going to show you that over and over again. Next, square root on both sides. And then it looks like here I've got x minus 2 equals plus or minus root 3. Add 2 to both sides. And you get x equals 2 plus or minus square root of 3. Square root of 3 is about 1.7. So 2 plus 1.7 is about 3.7. 2 minus 1.7 is 0.3. So it looks like my two answers are about 0.3 and 3.7. Moving forward, how can you complete the square? Well, method of solving quadratic equation, or what is it? It's a method of solving quadratic equations that doesn't involve factoring in the traditional way. And the key step is adding b over 2 squared to both sides of the equal sign. Take a minute to look at the steps here for completing the square. So words, to complete the square of the expression, follow these steps. Find half of b, the coefficient of x, which is the linear term. Square is a result from step 1. So b, half of b squared, and then add that result to x squared plus bx. In algebra, what we're saying is x squared plus bx plus b over 2 squared, which would give you x plus b over 2 squared. Okay? Take a minute to let that sink in. One of those 3 ways of doing things probably works for you. That is the same thing said twice or 3 times. Once in words, once as instructions, and another time as algebra. So find which one works for you, and we'll move on to the next step. Moving on for us, we are looking at a few exercises that are just completing this square. So let's take a look at number 2 first. Your first job in completing the square, and I like to do this first part just kind of off to the side of the problem. So the first thing is to figure out what is b, and b is a number that is attached to the linear term. So I'm getting b is equal to negative 14. Now we're going to take that value of b and divide it by 2. So b divided by 2 is negative 7. Now you'll notice that I've highlighted that because that is going to be important to our solving. That negative 7 is an important number. Next thing you're going to do here is to take that negative 7 and square it. So b over 2 squared is 49. And if the b over 2 stuff confuses you, don't worry about it. The important thing is that you're taking that number, dividing it by 2, and then squaring it. Okay, so how are these important? Well, the first thing that we're going to do is we're going to take that 49 and we're going to add it to the equation. And then finally, we're going to factor, and we're going to cheat factoring by just saying it's equal to x minus, or x plus the yellow number squared. Okay, so you add the blue number to both sides of the equal sign, and then you factor by saying it's x plus whatever the yellow number is. Okay, let's take a look at number 6, because I think that's going to look like it's a really difficult question for us. Let's try it out. Number 6, what is b? B is 11. What's 11 divided by 2? It's 5.5. Now here it's going to be useful for you to use a calculator. 5.5 squared, 30.25. So to complete the square, you're going to have to add 30.25 to the quadratic equation. And then to factor, it's just going to be x plus 5.5 squared. So it seems as like we're doing a lot of math here, but really in essence, we're only doing a couple of operations and trusting that our factoring is going to work out the way that we plan it to work out. We're going to bring this factoring or completing the square into use in a more in an actual equation this time. So let's take a look at question 9 and just taking a look, is this in the form of x squared plus bx equals d? And of course it is. We got x squared plus 7x, so b is 7, is equal to 30, so d is equal to 30, but of course, as I've been telling you, that d, the value for d is not important. So if b is 7, the next quantity that's important to us is b divided by 2. That's 3.5. Don't let the decimal scare you. And then the next number that's important to us is 3.5 squared. 3.5 squared is 12.25. So taking a look at the original equation, I'm going to add 12.25 to both sides of the equal sign. You'll notice over here that we have that 12.25, as in yellow, is going to be on both sides of the equal sign. The left side is going to factor out into x plus 3.5 equals whatever the right side adds to. And something that I forgot to do here for you is just to highlight that 3.5. That 3.5 came from b over 2. Okay, next you're going to take a square root of both sides. And both sides means the left side of the equal sign and the right side of the equal sign. When you take the square root of the left side, all you're doing is removing the square. And if you take a square root of the right side, you're basically just asking your calculator what to do. So the square root of 42.25 is 6.5. And of course, we mean positive and negative 6.5. You're going to you're subtracting 3.75 because you want to solve for x. And you get x equals, what is that, negative 3.5 minus 6.5 and negative 3.5 plus 6.5. Do a little bit of the mathematics and you get negative 10 and 3. So x equals negative 10 or 3. Okay. The next one we're going to look at, number 11, we're going to need a lot of space for this. So let's figure out what b, or whether or not we're in the same form. I've got x squared minus 12x equals 10. So that does look like x squared plus bx equals d. In this case, b is negative 12 and d is 10. So the first three quantities that we're going to get, that are going to be important to us, b is negative 12, b over 2 is negative 6, b over 2 squared is 36. We're going to use all three, not all three of those, b over 2, negative 6, and we're going to use b over 2 squared, 36. So the first thing is to add 36 to both sides. We're going to use that number also in a second. Kind of put things out of order a little bit. Sorry about that. So we're adding 36 to both sides and factoring. And so you get x minus 6 squared equals 46. That's why you have that square root of 46, because when you take a square root of both sides, you'll get x minus 6 equals square root of 46. What is the square root of 46? Well, I just showed you over there. It's, that way. It's 6.78. So x minus 6 equals plus and minus 6.78. Add 6 to both sides. and you get x equals 6 plus or minus 6.78. Remember, that's two equations, so we're going to solve both of them. You got x equals 6 minus 6.78, which is negative 0.78. You get x equals 6 plus 6.78, which is 12.78. So those are our two answers. Okay, let's take a look at the next section. The next one that we're going to look at is question 18. This is on the more difficult side of things that you'll have to do. And the first thing that you're going to notice with number 18 is that a is equal to 12. So we need to make sure that this is in the correct form, which is x squared plus bx equals d. And that's not what I'm seeing here yet. So the first thing that I'm going to do is divide everything by 12. And the algebraic way to divide everything by 12 is to multiply everything by 1/12. Okay? Don't let that, weird you out. You're just dividing by 12. Multiplying by 1/12 is just dividing by 12, and, just deal with it. That's the way it looks. Okay, so we're going to divide everything by 12, and you're going to get a couple of fractions here on the left side. You got x squared minus 2/3 x minus 1/6 equals 0. You need this to be in the form of x squared plus bx equals d. And right now you have x squared plus bx plus c equals 0. So you're going to take that 1/6 and you're going to add it to both sides here. Okay, now that you've done that, you're getting, what is this? X squared minus 2/3 x equals 1/6. That means that b is negative 2/3 and d is 1/6. So we're ready to go with completing the square. So already we've done a lot of algebra just to get it into the correct format. That's what makes this so difficult. But now that we're in the same format, barring any mishaps with the fractions, this should go pretty simple. So the first thing to do next, I don't know why I keep saying the first thing, but the next thing we should do is figure out what b is. Divide it by 2 and then square. So you got b over 2 is negative 1/3. That's going to be used when you factor. And b squared is 1/9. That's what you're going to add to both sides. So moving from here, you're going to add 1/9 to both sides. Okay, here we go. We've added 1/9 to both sides of the equal sign. And just as some addition, you've got 1/6 plus 1/9 is 15 over 54. Factor both sides, you get the quantity of x minus 1/3 squared equals 15 over 54. Remember that you're not really factoring, you're just saying x plus b over 2 squared. Square root on both sides. There's our square root, and you'll notice that now I've turned everything into decimals. X minus 0.33 equals plus or minus 0.53. So we're dealing with some pretty small numbers here. Now we're going to add 0.33 to both sides, and we get x equals 0.33 plus or minus 0.53. Let's break down those two solutions. 0.33 minus 0.53 is negative 0.2, and 0.33 plus 0.53 is 0.86. So that's a lot of decimal work that you had to do here. And then also there was a lot of prep work you needed to do before you even completed the square. But hopefully the completing the square part is pretty easy. We're going to shift gears now as we go to number 20. So let's see what we got with 20. Number 20 is actually a little bit of a flashback to what we were doing earlier. You'll notice that this says just determine whether the quadratic function has a maximum or minimum value. And that's a combination of two things. We have a maximum if a is negative, and we get a minimum if a is positive. So we're just taking a look at a. And then the second part of this is to find that value. And to do that, we need to find the x-coordinate of the vertex, which is the same thing as the axis of symmetry. And then after we find the x-coordinate of the vertex, we're going to substitute that into the equation to get the y-coordinate of the vertex. The y-coordinate of the vertex is the maximum or minimum value. So look at 20. Let's figure out what the value of a is, and you'll see that a is equal to 1, which is positive. And if you have a positive value for a, that means that your parabola has a minimum. So we have a minimum value. Whatever we get from the vertex will be our minimum value. Next, let's find the value of the vertex, which starts with the axis of symmetry. Axis of symmetry, the equation for is negative b over 2a, which is, in this case, negative 6 over 2 times 1. Negative 6, 2 times 1 is 2. So negative 6 divided by 2 is negative 3. That's my axis of symmetry. Now that I have my axis of symmetry, just substitute that into the original equation. There's the original equation. And when you substitute that in, and then you do all the multiplication, y equals 9 minus 18 plus 10. And simplify that, you get y equals 1. Y equals 1 is the minimum value. I know it's a minimum because a is positive. Isn't that a lot nicer than completing this square? It's good of us to do a little bit of review here. I think the next one we're doing is number 24. So let's see what we have. Negative 4x squared plus 8x plus 12 equals 0. Notice that I'm not going to do any transformation or anything here. A is negative 4, which is, well, negative. So that means my parabola has a maximum. Therefore, y has a maximum value. Whatever the y-coordinate is of the vertex, that's going to be a maximum value. Axis of symmetry, x equals negative b over 2a. You can see how the numbers go in, and you get a negative 1. Substitute negative 1 into the equation. Y equals negative 4 times negative 1 squared minus plus 8 times negative 1 plus 12. Perform all the multiplication, including all the squaring. You get y equals negative 4 plus negative 8 plus 12. Now do all the addition and subtraction. And you get y equals 0. Since we already identified a maximum, y equals 0 will be the maximum value here. Onward to number 25. A diver jumps off a diving board. The function h equals negative 16x squared plus 6x plus 5 represents the height of the diver after x seconds. Normally we would use t to represent time, but I guess we're using x. I guess that's how you do in algebra. What is the maximum height above the water, and how many seconds did it take for the diver to reach the maximum height? Round your answer to the nearest hundredth. Okay. You really can't do a problem unless you know what the problem is asking for. Seems elementary, but I know I see a lot of algebra kids going around there just plugging in numbers, not knowing what they're looking for. So, reading is important here. So the first thing you want to figure out is, what is that maximum height? Okay, so what is the maximum height going to be? Second thing this question is asking for, how many seconds did it take for us to reach the maximum height? So we're going to have two answers here. One is height, one is seconds. So let's take that equation here. And remember that the maximum, since we're a second degree equation, the maximum is going to be the vertex. So we're going to do exactly the same thing we did before. To find the vertex, we first find the axis of symmetry, negative b over 2a, which is negative 6 over 2 times negative 16, which I didn't write it there, but that's negative 6 divided by negative 32, which is 0.1875. Again, that's a scary looking number, but don't let it worry you. You have a calculator. That's why you have a calculator. Let's take that number, and you're going to substitute that number into h. Okay, negative 16 times 0.1875 squared plus 6 times 0.1875 plus 8. Do all the multiplication. You'll get negative 0.5625 plus 1.125 plus 8. Do all the addition and subtraction, and you get 8.5625. So the maximum height is 8.5625. When does it occur? It occurs at 0.1875 seconds. Okay, guys, I know all of these for chapter 9 have been taking a long time, but, as far as I'm concerned, this is when we're actually doing some real math. Not that we haven't been doing real math, but now things are real. Even the calculus students out there are going to say that this is some real math that you're doing and not some baby stuff. Heck, I bet even some of the mamas and papas out there are not very familiar with this math. And if they are, good for you. They're a valuable resource to you. Anyways, that's it for section 9.4. Yeah, 9.4. And I'll see you guys tomorrow with some more wonderful math. See you later.